All right, guys, we're moving to Chapter 13. Aggregation, composition, and inheritance. Inheritance is really, really important. We could conceivably spend all the remaining weeks talking about it. Yeah, I don't think that's going to be the case because there's a couple other things I want to do, like multi-threading and accessing the internet and operating system file I/O access. But let's take a look. Let's take a look at what we got here. Composition, aggregation, UML class diagram. All right, let's go take a look at that. Composition. All of our projects have been relatively simple. We've been able to describe each object with just a single class. But for an object that's more complex, you might consider breaking up the object into its constituent parts and defining one class as the whole and then other classes as part of that whole. Right? Just like you buy a car, it's made of a whole bunch of other things, right? It's got an engine, got wheels. Wheels can be of different types. So maybe you need a wheel object, and maybe you need an engine object, and then the car object, car class is going to be composed of a wheel object and, or 4 of them, whatever, and an engine object, and so on. So one class is going to be the whole, and then the other parts are going to be parts of the whole. That's one way that we're going to discuss this. When the whole class is the exclusive owner of the parts classes, then that class organization is called composition. So for example, if you have a car, it's got its engine, right? And it's got its wheels. Now those engines and that engine and those wheels are owned exclusively by that one car. So they're not shared, right? We don't have one engine being used by 2 cars. All right, I can see some errors in this example, but let's just roll with it. So this is called composition. When the whole class is the exclusive owner of the parts classes. The engine and the wheels are entirely owned, right? Exclusively owned by the car class. But then you also have something called aggregation. Aggregation is when the parts can be shared by more than one whole. Well, that sounds weird, but maybe it's not, right? You have books, and they're on interlibrary loans, so they can go between libraries. Or, better yet, you have students. Students go to classes, but a class, students can go to more than one class, right? So you might have a class that contains students, but those students could be shared between more than one class, right? When the parts can be shared among classes, by the whole classes, this is aggregation. Put some quotes around that because it's really important. Put that there. Okay. All right, so there we go. So we're going to be talking about composition versus aggregation. Aggregation is when the people can be shared, when the things can be shared by more than one object. Whereas composition is when one object completely owns the sub-objects, the components. So the idea of composition is not new. It's how we think of the world. It's how we describe complex objects in the real world. Every living creature and most manufactured products are made up of parts, right? I have my own legs, you have your own legs, right? We're probably not going to share our legs. So often each part is a subsystem that is made up itself of its own subparts, and it forms a composition hierarchy, right? My toes are part of my legs are part of my body is, part of me. Note the human body composition on the next slide. Remember that with composition relationship, a component part is limited to just one owner at a time. A heart can only be in one body at a time. Maybe I should come over here and revise this. I'm going to say, and the owner, i.e. whole class, is the exclusive owner of the parts classes. And students can be shared by more than one class, or the parts can be shared among more than one owner. That is aggregation. So the human body, it's got a brain, it's got a heart, it's got a stomach, it's got bones, it's got muscles. Every muscle is made of cells. Each cell has its own nucleus, mitochondria, molecules, and atoms. Of course, every one of these is made by atoms, but the bones atoms do not live in the muscles atoms as well, as vice versa. So this is known as a has-a relationship. Each human body has a brain and it has a heart. But there's another has-a relationship called aggregation. They call it a weaker form of composition. One class is the whole, and the other classes are parts of the whole. But there's no constraint that requires parts to be exclusively owned by the whole. So you can implement a school as aggregation. You have a whole class for the school. You have parts classes for the different parts. And then you have the different people who work and study at the school. The people are not exclusively owned by the school. So that could be more than part of one aggregation. For example, a person can attend classes at 2 different schools and be part of 2 school aggregations. The same person might even be part of a 3rd aggregation of a different type, like households. So a car dealership program. We think about a car dealership. A dealership contains 3 classes. It sells cars, it's got managers and salespeople. So, dealership and cars. Are the cars shared between dealerships? And I'm not thinking so, unless you have like a family of dealers who all sell the same product, but it doesn't sound right. And then a dealership salesperson and a dealership manager. Let's see what their diagram says. Notice this little symbol for the UML. We have these black diamonds and then we have these white diamonds. What they're saying here is that a dealership exclusively owns its cars. However, the manager or the salespeople could go and moonlight at another dealership, right? You know, they have 2 jobs, and so they can be shared by more than one dealership. This is saying that it's a one-to-one relationship, so every dealership has one manager. However, the manager may work at more than one dealership. This is a one-to-many relationship. One dealership owns many cars. And over here, it's a one-to-many. One dealership has many salespeople, but like we said, the salespeople may also work at other dealerships. So if it's a black diamond, that means the cars are exclusively owned by that dealership. If it's a white diamond, it's an aggregation rather than composition. So the manager may be owned by more than one dealership, and the salespeople may be owned by more than one dealership. It sounds bad when I'm saying owned, but you get it. So that's the association. So inheritance overview. Different ways that classes can be related. We've talked about aggregation and composition. Those are known as has-a, right? The car dealership has cars. Has-a, right? A car dealership has cars. A body has tissues, and so on. So that's composition and aggregation both, right? However, there are also is-a relationships. right? A tiger is an animal. A Ferrari, whatever, is a vehicle, right? So that's the is-a relationship. That is done via inheritance. So inheritance is another type of class relationship. So creating a more specific blueprint that's based on the existing master blueprint is analogous to the concept of inheritance, right? So you have a person class, right? And you have two different kind of people, or three different kind of people, right? You have employees, you know, and you may have hourly employees and you may have salaried employees, right? And you may have students. Those are all people, right? So you could use inheritance. You could define a person, and then you could make the hourly employees and the salaried employees subclasses of the people class. Inheritance is a very important feature of Java and all object-oriented programming languages. Let you reuse existing software. Once I've implemented my people class, right, and all the classes that inherited from it, I could use those in more than one project. So we have a person class. Every person has a name. We also have a customer. Customer inherits from person so that every customer also has a name, but they then have an address. This is known as the super class. It doesn't mean it's more powerful than the rest of them. It means it's more generic. This is the subclass. Subclass doesn't mean it's lesser, it's actually got more, right? Because every customer inherits the name and also has an address. And then you've got employee, right? Every employee is a person, so every employee inherits the name field, but it's also got an employee ID. And then a full-time employee might have a salary, and a part-time employee might have an hourly wage. So the part-time class is a subclass of employee, which is a subclass of person. Person is the superclass to employee. Employee is a superclass to part-time. As you go down the hierarchy, the classes get more specific. This is a generic person, so it only has a little bit of information. By the time we get down here, the part-time class has 3 bits of information, right? Got the wage, the ID, and the name. So it gets more specific as we go down the hierarchy chart. So within an inheritance hierarchy, pairs of classes are linked together. The more generic is called the superclass, right? Higher up the chart. And the more specific is called the subclass. So we say that subclasses are derived from superclasses. He derives from person. Part-time derives, whoopsie, from employee. Maybe we ought to do a little bit of this actually in Java. So I'm going to go ahead and open up. I believe we're on Lecture T. Apache's not loading. How about it? Okay, fine. All right, I think we're back in the saddle here. Lecture T. Alrighty, so creating our little project. Trying to think, are we going to do their idea of a car dealership, or are we going to do our own? I think we ought to do our own. Although the employee idea, is that where they were going next with this, the employee idea, or where they're taking this with the people class? I just don't want to do exactly what they're doing. However, it's very comprehensible, the idea of a person. We might do that, but I'd rather do a Pokemon class. Let's do Pokemon. I'm just going to wing this. Hopefully it'll make sense. What is our Pokemon going to have, right? We're going to have a specific kind of Pokemon. or excuse me, a generic Pokemon, right? All it has is a name, right? And maybe a region where you know the Pokemon type comes from. All right, and then we're gonna have some subclasses, right? We're gonna have fire Pokemon, water Pokemon. All right, I'm kind of already running into a little problem here because I don't know exactly what I'm going to make as far as their special attacks are and whatever. But so what kind of attacks does a fire Pokemon have? Well, he could have a blast burn, right? He could have a fire punch. We're going to come up with 3 of these. And he could have, I don't know, fire spin, right? And then we could have a water Pokemon. Well, fire Pokemon is going to be descended, inherit everything that a generic Pokemon has. Well, every Pokemon may have a number of hit points, right? And then the water Pokemon got his own attacks. And let's just come up with a couple of those, right? You might have one called Bubble. That's a movement, that's not an attack, right? Alright, so what can a water Pokemon do? Scald. They can scald the opponent. They can use water gun on them. And then they can do Bubble. And slow the opponent's speed down. No, we're not going to go all full bore and make all this actually happen. If we were really awesome, what we would probably do is make these attacks, make these moves their own class, and then each kind of Pokemon would be able to, you know, you could attach those to that. Instead, we're just going to make these like the number of attacks they have, right, or true false. Do they have a blast burn? Do they have a fire punch? Do they have a spin? Do they have a scald attack? Do they have a water gun attack? Do they have a bubble attack? Okay, so I think this will work. Let's work on our generic Pokemon first, right? I'm going to come over here. And remember, every object, every class should be in its own class. Am I going to try to follow that? I think that wouldn't be a bad idea, just for the practice. So I'm going to come over here and I'm going to add a new project to my current lecture. We're in Lecture T, right? Where's Lecture T? Down here in parallel with our current main. Right click on that. Do new Java class. It's going to be Pokemon. All right, so every Pokemon has a name. It's just a common, right? String name. And every Pokemon has a region where it's come from. String region. And lastly, every Pokemon has a number of hit points, right? HP for short. Now, honestly, I haven't played any of the Pokemon video games except for a couple, you know, Battle Royale style, so I don't know, you know, how this compares to the old Game Boy games or whatever. I'm just making this up as I fly. I remember the old cartoons, kind of going from that. All right. Now, what would we do if we were good little programmers? Would be to encapsulate these guys and add getters and setters for them. In the interests of making this example as clear as possible rather than as correct as possible. You see there's two differences there. There's clear and then there's correct. Clear is for our educational purposes so that we understand exactly what we're doing before we start, you know, muddying up the waters with more, you know, academic correctness. By correctness, I mean, you know, encapsulating this stuff all with getters and setters and stuff like that, making these private. Let's just run with this. So we have a Pokemon. Don't really need all this here. But just to make this easy for myself, I'm going to say that this is file name Pokemon, not Java. It'll just help when I copy and paste this into the notes, right? And this is the superclass for all Pokemon classes. All right, so let's add another class in parallel, same folder as this one. Go into the default package, right click. If you created a package, of course it'll be a sub package in there, but I know you can find your files. So new Java class, right, this is a fire type. The fire type has some specialty things involved, right? Let's just say that these are numbers, like you're saying. I believe what you really have is like an energy type, and each attack costs a certain amount of energy. Maybe we can do it like that. Nah. Just for ease of purposes, we're going to say we're going to list the name of the attack and the damage that it costs, right? That it gives. Blast burn, right? Fire punch. And fire spin. But it inherits from the other class. It's not a class all by itself. So it extends the Pokemon class. So fire type is a subclass of the Pokemon class, meaning it gets everything the Pokemon class has, plus the additional members. Alright, so we have created one kind of Pokemon class. I'm going to go ahead and create the other one right here just while we're looking at this one, but then I'm going to cut and paste it into a new file, right? The next one's going to be called water. So public class fire type extends Pokemon, right? And it has its own three things, right? It's got oh, I hope I wasn't typing up the screen earlier when I was creating water Pokemon attacks, right? Here's what I came up with. Whatevers. All right. And so Scald, int water gun, and int bubble. Oh, it's not liking the fact that I have the word public here because each file can only have one public. It's about time to spin this one off into its own file. Don't need my name on this. File name. Fire type. Extends Pokemon, meaning it's got an is-a relationship. A fire type is a Pokemon. All right, let's go for it. We're going to make the other one. So in parallel with fire type and Pokemon in the same package, new Java class, water type. All right. I'm just going to cut what I previously had, right? File name. Apparently I copied the wrong one. Oh, I never gave it the word water type here. All right. So public class water type extends Pokemon. Oh, great. When I created the name, my keyboard skipped and it's got two Y's in it. Yeah. You know what? I'm just going to undo everything and then I'll fix that with a little bit of refactoring, right? Okay, since I gave it a dumb name, it does extend Pokemon, but I'm going to rename it to correct that water type. So I'm going to double click that and choose refactor, rename, and this will just rename the file. It's the fastest way of doing it. Water type. right, I'm happy enough. Okay. File name watertype.java extends Pokemon because a water type is a Pokemon, and a water type has a relationship to these various attacks. All right, that's about enough of that. Now let's go back to main and create a Pokemon of each type. It would be nifty slick if when we created the monster, the pocket monster, we could assign it its name and its region and its hit point all at one time. So we might want a groovy cool constructor that does that, right? So public Pokemon, because a constructor is a method that has the same name as the class, no return type, and then has optional parameter variables for assigning values to it. So string name, comma, string region, comma, int HP. This hyphen name equals name, hyphen greater than, wait, sorry, I'm slipping into C++ there. This dot name equals name, this dot region equals region, and this dot HP equals HP. Alrighty. Blipping back over to main. File name, lecture T.java demonstrates the Pokemon class and its subclasses. Alright, down here, we're going to create a fire type. Fire type, Charmander. Wait, that's not how we do it. I mean, it's how we could do it, right? But it's Pokemon too. Or it's a Pokemon, so we're going to call it P1. Poke1. Or I could just call it a word Charmander, right? Charmander equals new fire type. Alright, now I've made a mistake in how I set this up. This isn't even going to be able to give those three types of pieces of data to the Pokemon. It's not using this constructor. We could make it use this constructor, but it's not right now. Sorry for typing all that in. I'm just going to delete that wholesale for now. We'll find out how to make a subclass call the parent's class the superclass's constructor, but not right now. Okay. So back to main. That's our fire type, and we need to set its data, right? Now I kind of wish I hadn't called it something so long. I'm going to rename it back to Poke1 because that's easy to type. Poke1 dot name equals quote Charmander. Poke1 dot region is equal to Johto. I don't even know if that's a valid type name, but Kyoto. Looks better, huh? I don't know what I was thinking of. Oh, there is one called Johto. It's just I spelled it incorrectly. All right. So it's Johto. All right. And his hit points. Poke1 dot HP equal. He's got 100 hit points. But he's got some specialty stuff. Every Pokemon's got these things. He's got some specialties. Poke1 dot Blast Burn. His Blast Burn attack does 20. Pokemon dot Fire Punch. His Fire Punch does 10. And Poke1 dot Fire Spin does 30 damage. And we're not going to actually implement all this. This is just to illustrate the concept that a fire type has these attributes which it inherits from the Pokemon type, from the superclass, and then it has some extra abilities all of its own. All right, now let's make a water type. Water type Poke2 equals new water type. His name, Squirtle. Or its name. They all seem to be genderless for the most part, with some exceptions. All right, this one's region. Is Hoenn. All right, and Pokey, Squirtle's got fewer hit points than Charmander, let's say, so Poke2.HP is equal to 80. However, we're going to give it some really awesome attacks. It's the most lethal Pokemon of all. So Poke2.Bubble, its bubble attack is 40. Poke2.Scald does 50. And Poke2.Water Gun is equal to 60. So he's hecka awesome. It's hecka awesome. All right. Hopefully that makes sense. I don't even think I'm going to do anything else with this particular class, because as I was creating it, if I'd come up with a better concept in advance, or we had made the attacks list what they were good against, right? What kind of Pokemon they were good against and what kind they were not. The different attacks, different Pokemon are resistant to different things, right? And how much energy they use, as well as hit points they deduct from the opponent or whatever, right? We could have made this a really complex example. And I've had people implement a Pokemon game as their project. It was kind of cool. They did it pretty much all with strings, actually, to list which one, and they did not use inheritance. It wasn't for Java, but they could have. So I think this is enough just to demonstrate the idea of inheritance. We have water type, which inherit from the base class of Pokemon, and we have fire type. Okay, so what are we going to do next? We're going to demonstrate just a wee little bit of what is known as polymorphism. Polymorphism is when objects are treated in different ways, even though they're the same type. Well, each one of these Pokemon is a Pokemon. They're the same type. So let's make a method called display. Public static void display Pokemon. And I just leave it like that. And it takes a Pokemon PK as its parameter variable. Now what I'm going to do here is kind of a cheesy form of polymorphism. And what do I mean by that? We're actually going to check its type. And if it is a fire type, we're going to display something. And if it's a water type, we're going to display something else. It's better if you make the object capable of doing all that stuff itself. For example, if we put a display method, well, why don't we do this right? Let's go put a display method inside each one of these subtypes. And what I'm going to do is I'm going to go to the Pokemon class. I'm going to add a display method right here, right? Void display, parentheses in parentheses, and all it's going to say is I'm a Pokemon. I don't ever want to see this message because I want to use the display method from the classes that inherit. So system.out.println I am a Pokemon. We never really want to see that, so I'm not fleshing this out with really good information. But I'm going to copy that and paste it into the water type class or the fire type class and expand upon it. So inside the Pokemon class, we added a method. We're going to go to the fire type, and its display method is going to actually be useful. I am a fire type Pokemon. Now let's print out its information, right? Name and etc. System.out.println parentheses quote name equals end quote plus this dot name. Notice that when I typed in dot, it listed all the methods of the parent class, the superclass. Parent class is a term that's used in C++, I believe. Java uses super. These methods are part of the superclass. These methods are part of the subclass, and it kind of just is showing them interchangeably, right? Because HP is part of the superclass. These are parts of the fire type class, and it's just saying, yo, all of this is available to you. You don't even have to distinguish between the two, because a fire type is a Pokemon, so everything it has is available. So name equals plus this dot name. System.out.println parentheses quote, you know, region equals end quote plus this dot region. System.out.println parentheses quote HP equals end quote plus this dot HP. And we could print out extra information that was determined solely on this, right? I can't think of a clever way of doing this, so I'm just going to say attack moves equals blast burn, fire punch. And fire spin. Like I said, really this should probably be an array of some kind of class called moves, right? And we can step through the array list of those moves. But this is going to demonstrate the point. So that's our method for displaying. Let's go and add the same kind of stuff. To make it easy, I'm going to I'm going to copy all of this stuff from the fire type. And paste it into the water type class. So each of these subclasses has its own version of the display method. They inherit a version of display. So, tell you what, before we do that, I'm going to undo that. We're going to say that fire type is a super sophisticated version of display, but water type just inherits it from the superclass. So I didn't change water type at all. I'm going to go back to main. I'm going to call our display method poke1.display, parentheses in parentheses, and then poke2.display. So far it seems like we don't even need this method. I may leave it just for future purposes. We might expand upon it. Alright, so when I run it, since the fire type has a very specific version of display, we're going to get a lot of information out of it. Since the water type doesn't have its own custom version of that method, it's going to use the one that inherits from its parent, from its superclass, which was just that I am a Pokemon method, right? So here's all the information about the fire type Pokemon, but water type did not have a display method, so all it did is use its superclass's version of it. Let's go and create a display method for the water type as well. I'm just going to paste it, what I had copied from fire type. I'm going to change this to say I'm a water type Pokemon. And I'm going to change the name of the attack moves, right? This one's got Scald, Water Gun, and Bubble. Maybe to be really cool, I'm going to dab these things over a bit so that when they finally get displayed, it's a little bit clearer. I'm going to do the same thing for over here for water type. All right. So we run it. We have a fire type Pokemon named Charmander with that associated information. And we have a Squirtle water type with that associated information. These 3 bits of information, chunks of information, are inherited from the superclass. And this information is specific to the fire type, to the subclass. Same deal with this. These are inherited from the parent class. And this is special information that is germane only to the water type. So we've shown inheritance and is a relationship because a fire type is a Pokemon and so is a water type. If you've done C++ programming, your C++ classes can inherit, can extend multiple other classes. You could extend 2 classes or 3. It's not called extends in that language, but it's what it does. It implements or it inherits from 3, 4, 5 different classes, and that can get really extraordinarily confusing. Java did away with that idea, but they came up with the idea of a different class called an interface, and you can implement as many interfaces as you want, and so that's how they got around the idea of making an object extend multiple classes. Instead, it extends only one class. You say it is a Pokemon, but then it implements some other things based from another class. That'll be a lot clearer upon the next lecture. All right. So here, they're person class. Remember, they're doing this business to where we have a person class and a customer subclass and an employee subclass. So their person class, they just made it look like this. When you create it, you can pass in a constructor. That is a name. And it also has a getter. They were better programmers than we were. They made this member private. The person class, that's the same slide. All right. The employee class extends the person class, and it has its own constructor. The constructor has name and int. And the implementation for that's actually hidden down here. And so what are they doing here is that this constructor would set the ID, this ID equals the ID that's passed in. But then since that data was private to the superclass, to the person class, the name, then we could not set this .name because name's private from the class we are inheriting from, that we're extending. So instead we have to say set name because we inherit that method. It's a public method that's part of the person class, so we can call it from the child classes, the superclass, the subclasses. We pass in name like that. Do we want to be awesome and make our Charmander class? Our classes follow this technique? Sort of want to. Nah, I'm going to leave that example alone because I believe that it shows it adequately. And then the display information will print out some kind of information germane to it. But if we wanted a constructor and then the other object had its own constructor, something's bugging me about this, and that's not how you would call a super constructor. And they're not showing how to do it down here, are they? Alrighty. So, yes we can. Yes we can. This would not be a good way of doing it either. We probably really ought to do this correctly. So what am I going to do now? I'm going to go back to my code. I'm going to add a constructor for the Pokemon class. To make it easy, all it's going to do is take a name and a region. Well, why not all three? Whatever. Okay. So, or just its name for simplicity's sake. Pokemon, got to make it public since it's a constructor. All constructors should be declared public. Really, all these things should be declared deliberately public or private. But anyways, public Pokemon, and it's going to accept a name. And inside here, the name, this dot name is equal to the name. So I've just modified the Pokemon class to have a constructor. I believe this is going to break our code. Why is it going to break our code? Because the constructor has broken the other bits of code because nobody is calling this constructor. The child classes do not know how to call this custom constructor. As long as it was just a default constructor, it worked. We could provide our own default constructor right here and the code would be back to working. But instead, we're going to fix it over here, right? So where it says, constructor Pokemon cannot be applied to the given type, fire type. Actual and formal argument lists differ in length. So if we go back to our fire type and we add a constructor for it, public fire type, if we want to call the super types constructor, we do it like this. Let's go do the same thing to water. Public water type accepts a name. And it calls the super types, the parent's class constructor, passing a name in. Now when we go back to main, the constructors are broken because they're expecting a parameter to be passed to the constructor. So this is Charmander, right? And this is Squirtle. Quotes around them. So we don't need to set the dot name like that. Let's also allow ourselves to pass in the region and the HP. So this is going to be the region, quote, Johto, end quote, and then the hit points are going to be 100. So I no longer need these two pieces of information. I'm going to have to go back and modify the constructor for the fire type class to accept those two additional arguments. So, and this is that region, you've got 80 hit points. But we don't have a constructor that'll accept those 3 bits of information. We're going to do that. We're going to go back to the fire type class. The constructor is now going to accept a region and accept the hit points. What we really should do is make this constructor accept those 2 bits of information. But I'm just going to say set this dot region equals region and this dot HP equals HP. And for some reason I put a semicolon there, which breaks the code. All right. By the way, if you're going to call the parent's class constructor with the super keyword there with the super method name, then it has to be the first thing in your other constructor. That's why it's there. If I cut that and I pasted it so that it was last, that'd be a syntax error. Do not compile. All right, so if I go back to lecture T, that fixed the fire type constructor, but it did not fix the water type constructor. Let's go do that. it occurs to me. No, I'm not going to even tell what occurs to me. Let's go back in and do that as well. So for water type also takes a region and a hit points. And it sets this dot region equal to region, and it sets this dot HP equal to the HP that we're passed in. What I'm wondering is if this method could be made part of the parent class, and then each of the children classes don't even need a subclass with that information. If water type and fire type would not need custom constructors, if a constructor that looked like this, that took 3 parameters, were made part. But I don't want to mess where we are. It's going to work now. We have written something that inherits, that extends a class with 2 subclasses, and I think I'm pretty good with it. Still working correctly. I'm a fire type. My name is Charmander. Here's my region. Here's my hit points. Now I'm a water type. There's my name. There's my region, and there's my hit points. I want to give another lecture before I assign any homework over inheritance. So I'm just going to end this one here. Do be working on your projects, please. As I mentioned, I'm going to slow down on the homework just a little bit so that you have ample time to work on your projects. I hope this was clear though. You absolutely need to read this chapter. Don't just go based on my lectures, right? You got to look at the PowerPoints, got to read the chapter. You want the full understanding of it because this is pretty important stuff.